Another Leetcode problem, 234, Palindrome Linked List. So we are giving the head of a singularly linked list. Return true if it is a palindrome, or false otherwise. Yeah. So the straightforward way is that we can put it inside a result array, and then we're gonna start to tag, and we're gonna put the values inside of the result array. So yeah, so we're gonna append the head dot value, and we're gonna loop through the next. So head would equal to head dot next, and then we just need to return if this result would be equal to its reversed array. Yeah, if it is equal, we're gonna return true. Otherwise, we're gonna return false. And we use the actual space, as you know, it is the result array. Yeah. Let's start with for. Yeah, as you can see, the past end is pretty fast, but it is the actual space. And let's check the follow-up. Could you do it in on time and on space? Yeah, we did it in on time, but we did it in on space, so that is not okay. I mean, yeah, if it is an interview, definitely they will ask you the second question, the follow-up, if you do it like this. So we have to use on space. Yeah, so how can we do it in on space? I think the idea is the same. You know, if we put all the values inside an array, of course, it's gonna be really easy because we can use some libraries. Even if we didn't use the library, it's gonna be really easy. Yeah, because we are familiar with the array. But this is a linked list, so we're gonna solve it. Just like a linked list way, we're gonna solve it in space. Let's try to make a drawing. So we have this node like 1, 2, 2, 1. So basically, we need to use a slow and fast pointer. So we're gonna use the slow and fast pointer. Normally is used to solve such a palindrome linked list problem. Yeah, so we're gonna define two pointers, slow and fast. So first of all, we're gonna check how many numbers, how many nodes. So for example, this is 4, or maybe it is 5. It always depended on, depending on the examples. Yeah, we're gonna check if there will be 4 nodes or there will be 5 nodes in total. We're gonna solve it differently. But definitely we're gonna need a dummy node. We're gonna need a dummy node D ported to the first node 1. Yeah, because in this way we can use the slow and fast pointer to find a way to solve it. So for example, from the beginning, the slow and fast pointer ported to this D. D is the dummy node. And then the slow pointer, let me use another color. And then the slow pointer will be here, and the fast pointer with 2 dots will be here, and then the slow pointer will be here, and the fast pointer would be here. So we're gonna stop it because while checking, we're gonna use the while fast and fast dot next. If the next did not exist, so we're gonna stop it. So from here, we can separate the array into 2 parts. So this is the first part. So from the dummy node to node 2, and another part is just from node 2 to node 1. So while checking, we will not check the dummy node. So we're gonna check with the node 1 to 2 and node 2 to 1. But we can reverse it. 2 to 1, we can reverse it 1 to 2, and this is also easy. Yeah. So after that, we're gonna check the values. If this 1 equal to this 1, this 2 equal to this 2, we're gonna return true. If any value is not equal, so we're gonna return false. Yeah, so this is for the node if the node is even, but what if the node is odd? So let's try to use another example. Maybe the number of node is not even, it is odd. So for example, we have a node 3, and let me use a node 1 maybe. Yeah, maybe we have another node 1. Yeah, so this gonna be node 3. This gonna be node 2, and this gonna be node 1. As you can see, this is also a palindrome because 1, 2, 3, 2, 1. This is also a palindrome, and we're gonna do it similarly like before. So we're gonna prepare a dummy node. So this gonna be the dummy node, and the slow pointer and fast pointer will be starting from here, and then slow pointer will be here, fast pointer will be 2, and then slow pointer will be 2, and fast pointer will be this 2. And then slow pointer will be 3, and fast pointer will go out. And now we're gonna stop the while loop. Yeah. Now as you can see, here is the slow pointer, but we need to separate it into 2 parts. Yeah, so we can just stop it from here. We will not check the slow.next, use it as another linked list. We just stop it here. We're gonna start from 3 to 1. And another array is 1, 2, 3. We just need to check 1, 2, 3, and this one after reverse it's gonna be 1, 2, and 3. We're gonna check one by one. If any number is not equal, we're gonna return false. If they are all equal, we're gonna return true. Yeah. So this is the whole idea of how to solve it. Now we just need to realize the method. So first of all, we're gonna check how many nodes in total. So yeah, because we're gonna use the head pointer later, so we're gonna use a p pointer as the head. So while p, we're gonna check how many numbers. So total should plus equal to 1, and p should equal to p dot next. So this is the first way. Currently, we have the total number of nodes. And then we're gonna use the slow and fast pointer. We're gonna use a p node, dummy node should be linked list, and p dot next should be pointed to the head. And then we're gonna use the slow and fast pointer strategy. So while fast and fast dot next. Yeah. Now we're gonna check it. So slow would be equal to slow dot next, and fast would equal to fast dot next dot next. Yeah. Now, after looping through the slow and fast pointer, basically we know where is the midpoint. Yeah. But for the midpoint, we need to check the total. If this total modular 2 equal to 0, it means it is even. So the next pointer, let me define it as L2 maybe. It's gonna be the linked 2 pointer. It's gonna be the slow dot next. So otherwise, if it is odd, so the L2 will be equal to slow. Yeah, as I explained earlier. Now what we need to do, we need to define a reverse function. So I'm gonna call it reverse. Let me call it reverse linked list maybe. Yeah. Inside we're gonna use a prev and current node. Yeah. So this is for writing the reverse function. I'm gonna give a pass at the moment. Yeah. So I'm gonna use a pointer p2 as the reversed linked list. Yeah, this is for the second part. So the p2 would be equal to yeah, reverse linked list, and inside I'm gonna give a noun as the current node. It will be L2. Yeah. Now I have two linked lists. One is the start from the head, another is start from the p2. So I just need to check while head and p2 if they exist. Yeah. So if the value is not equal, while head dot value are not equal to p2 on dot value, I'm gonna return a false. Otherwise, if they are always be equal, I'm gonna return true. Yeah. How to return a true? Yeah. I cannot type. Let me type a true. Yeah. Otherwise, we're gonna return a true. Yeah. But we need to shift the head should equal to head dot next, and p2 should equal to p2 dot next. Yeah. So up to now, what are we missing so far? We are missing the reverse linked list. So if you are familiar with how to write how to reverse a linked list, it's gonna be easy. So for example, if we have like 2, 1, so we have a linked list 2, 1. How to reverse it? Yeah, we have a previous node. It's gonna be the previous. Yeah. So first of all, we're gonna find the next. So this is the current. So current is C, and this is yeah, current is C, and this is next. So what is our first step? First step, we're gonna find the next, and then the current dot next should be equal to previous. So it's gonna be pointed to previous. Yeah. And after that, we just need to shift the previous and shift the current. So the previous should be equal to the current, and current should equal to the next. Yeah, as you can see, it is not so difficult. Now let's just realize it like this. So yeah, so we're gonna check the while current. Yeah, so the next node would be equal to current dot next, and current dot next would equal to previous, and then we're gonna shift the previous and current to current and next. Yeah, and finally, if the current not exist, we're gonna return the previous. So this is gonna be reverse of a linked list. Yeah. Now this previous will be ported to P2 because P2 would be equal to this previous. So we're gonna check it from the head and from P2 and check it one by one until we find an answer. Now, as you can see, it is a lot of lines of code, but it's not so difficult. Basically, you need to understand. You know, this is not so difficult. Count how many numbers of nodes inside a linked list, and this is a normal way of solving, yeah, the total number if it is odd or even. And this is a slow fast pointer. This is also an easy problem. And yeah, I mean up to here it's an easy problem. We use the slow and fast pointer. And up to here, reverse linked list, it's an easy problem. And up to here, this is another easy problem. We just compare the values. Yeah, it means that several easy problem becomes a made problem if we want to solve the O1 space. Basically, I think it's gonna be a made problem. Normally, easy problem cannot be appeared in a real interview. They have to ask the follow-up questions. I'm not sure. Let's just run it to check if it works. Yeah, it seems there's something wrong. Let me check. Yeah, I didn't define the slow and fast pointer. Yeah, I have to define the slow and fast pointer. So slow equal to fast should be pointed to P. Yeah. Now let's try. Yeah, as you can see, it works. Yeah, now let me just submit it to prove all the solutions works. Yeah, as you can see, it's pretty fast and it works. And the time complexity is O(n) and the space complexity is O1. As you can see from here, we didn't use any actual space, and reverse a linked list, we didn't use any actual space, and here we didn't use any actual space. Thank you for watching. See you next time.